All right, let's go ahead and get started, folks. Good morning, good afternoon, and good evening, depending on where you're joining us from the world in the world today. I'd like to welcome you to today's Endevor Community webcast. Before I hand you off to Dan, our presenter today, just a few things that I need to cover. First, if you have questions during today's webcast, and we always hope that you do, please use the questions box along the right-hand side of your screen to ask those. We'll get through as many of those as we can during our time together today. And if for some reason we don't get through everything, if we run out of time, or if Dan has to do a little bit of research, or we have to figure out the best answer for you, I will make sure that I capture your question and your contact information so that the team can follow up with you later. Your lines are all muted. That's because we are recording today's session. The replay will be available probably later today, or worst case tomorrow morning, out in the Endevor community. And the last thing for me is that we want to make sure these sessions are as valuable, because we appreciate you giving us some of your time today. So with that in mind, I pulled together a quick survey that will pop up at the end of the webcast. If you could stick around literally for 60 to 90 seconds and give us some feedback, we would really appreciate it. That's it for me, so take it away, Dan.
All right. Hello, everyone. This is Dan Walther speaking, also known as Joseph Walther. You can tell by the email address. I'm a long-term advocate of the mainframe and Endevor, and then more recently an advocate of mainframe modernization. Today, I'm going to talk to you about Table Tool. It's a utility that is a part of the Endevor product, but it has a lot of widespread, diverse usage, and we're going to try to attempt to demystify that today. And let's go forward. You're probably used to this. This disclaimer basically says that this presentation is for information purposes only. And here's what we're going to do. We've done presentations on the table tool before, but today we're going to concentrate on a certain realm of the use of the table tool. We're going to emphasize how little effort is involved to get the results that you can gain from using the tool. We're going to show how you can use JCL steps as the building blocks for building the process of the table tool. We're going to concentrate on the comma separated value inputs. Table tool allows multiple kinds of inputs, but there's been very little presented on the comma separated value, and some of the mystery comes with the comma separated value kind of input, so we'll concentrate on that today. And because we keep calling it as a diversified tool, the best way we know how to show that is by presenting examples. So one of our examples today will have nothing to do with Endevor. And the point there is to show that this tool is not just an Endevor tool. So we'll walk through several examples actually, and we'll show you what the output looks like. And we'll show you what kind of effort went into producing that kind of output. And there are a number of examples that we'll walk through that way, and every one of them plus many other examples of the use of the table tool you can find at this GitHub site that you see kind of in the middle of your screen. There are other examples that we won't have time to present today, but we'll at least maybe talk about some of them, and then we'll show you where you can get more information about the table tool. Okay, just a quick introduction. This is a different kind of an introduction that we've used before. Table tool is in many ways like other technologies, other kinds of things that you might be familiar with, like SAS, RPG, EasyTrieve, Telon. After this slide was produced, I thought actually, if you've ever used ICE tool, you could put ICE tool on that list. These are tools that you can use to avoid having to do a great deal of programming. In fact, many of these, you never see a read or write statement. You have just snippets of code as opposed to entire programming languages. Table tool is like that as well. At the same time, there are certain circumstances where you don't need any programming language at all. When you do have some programming language with the table tool, what you're writing is Rex code, and it's optional. You can see here on the slide, it's listed as optional. Rex is big on the mainframe. IBM has done wonders with Rex over the years. You can now embed Rex inside of a panel. That was not always the case. You can embed Rex inside of a skeleton. Rex is an interpretive language, does not need to be compiled, it's very easy to run. And you can use Rex to access DB2 tables. And more recently, IBM has empowered Rex so that you can make RESTful API calls. So Rex is big. Even Broadcom has some products that have Rex interfaces. JCL Check is one, Ops MVS are all big on Rex, on the use of Rex and making things happening. The other comparison that we're making here, if you're familiar with IBM's file tailoring, where you use what IBM calls a skeleton. A skeleton is like a painted output. Table Tool has something very similar to that. We call it a model. And as we go through the examples, you'll see, hopefully you'll see the similarities. First, we're going to talk about some of the input and output files that are used by the Table Tool, and we'll also venture on the next slide into some of the reserved words. There's an input file that Table Tool uses, and these are the DD names, by the way. The DD name of table is the main input file for a Table Tool step. And that's the only DD name that's fixed. These others are basically the default values. And when we get to the end of the presentation, we'll show you how you can build your own DD names for things that are the model, the table out, and the options. The model is the painted image of the output. That is the part of Table Tool that is more closely resembling an IBM skeleton. When records or rows of a table are selected for processing, those rows have variables and values that are used to expand the model, just like a file tailoring process would do. And the output is written to the table out DD name. The options are, again, completely optional. That's kind of redundant, isn't it? But you can include statements in Rex or not have any at all. And our examples that we're going to walk through today will show you some of the simple varieties of option statements that you can use. Some of the keywords. These are some of the keywords that the Table Tool uses and allows you to use to make things happen. You'll notice that the majority of these are variable names. These are all Rex-based variables, and their names begin with a $sign. Because Table Tool allows you to build variables that you want to use. You can make up some names, and we'll do that in some of our examples. As long as you don't prefix those names with a $sign, you're out of the way of what Table Tool is using as an internal reserved word. The first one is the table type. Again, today we're going to concentrate on the CSV table type, which is comma separated value. The Table Tool originally provided as the best practices implementation of Endevor, uses one of the other table types. And we won't really get into much of that today, but the last one listed here, the third, is the position table type. We'll have one example of that one, of that type today. Every time the Table Tool reads a row of the input file, it increments the next variable, the $sign row £. That's a Rex variable that tells you what was the last record read from the input file, the one that has the DD name of table. Skip row, $skip row is a variable you can use. If you see something on a row that you want to bypass processing for that row, you can set skip row to a yes or a Y, and that will cause Table Tool to just not produce any output for that particular row and go back to the table and read the next record. Strip data, we won't get into that. Build from model, one of our examples has a build from model. It's basically do the file tailoring exercise now. And you can name something like the skeleton, but we call them models. And we'll show you some of that in our examples. Also in the options, you can invent brand new variables, and you can make them up. You can assign their values to be values that are from the input file or elsewhere. We'll show you some examples of that. You can also code Rex statements to do just about anything. Okay, so now we're going into our first example. And this one, let me show you what that looks like. This is the output. This is a job that can be submitted to produce output like this. You might not like the format. That's intentionally done. I don't like the format of this output either. But this is the kind of thing you can do if you need a quick and dirty printed listing of something. This specific output has to do with, say for example, you have someone who left your team. They were supporting an application in Endevor, but now they're gone, and you need to find out what it was that they changed. Now, these standard Endevor reports can give you reports of the sign out information, but if you look at the element master of Endevor, you'll see that the sign out is usually cleared when you move this information to production. So this is an extract of Endevor information of all of the items that were last modified by a given user ID. So on the each time there's a hit, in other words, we find an element in the Endevor inventory that was last touched by this person, you can see there are 3 lines printed. Again, the format is terrible, but you can change it. That's the point of this first exercise. On the first line is the user ID of the person that we're doing this query on. So you can see in semi, and to the far right of the first line is the element name. And that's the element that was last modified by this person who we're searching through Endevor inventory for. On the second line, you'll see the Endevor system, subsystem, and type values. And on the third line, you see the date and the time when that item was changed by this person as recorded by Endevor. So what produces an output like this? It's 34 lines of JCL. And many of our examples today will show basically the same steps that you see here. There's a comma separated value step, and we're specifically talking about the CSV utility that is available from Endevor. And then there's a table tool step. Now we mentioned the options that are available and can be included or excluded. The options are executed by the table tool step once before the first record of the table is open, and then again after each record is read. So let's show you a little bit more about this. But before we show you the JCL, if you're not familiar with a comma separated value format, it looks something like this. You see a bunch of variables separated by commas, as the name implies. But most importantly, you see the first row is a row that has descriptive text for each column, logical column. So that descriptive text is text that the table tool is going to use for you. And if you were to run a comma separated value utility like the one that's used in this step, the heading that you would see is exactly the same heading that you would see here. Something else about the comma separated value data that's important to point out here is that you see that JCL is one of the element types, and you also see that copybook is an element type. They don't line up. In fact, they're kind of skewed. You can see JCL is a little shifted to the left, copybook is a little shifted to the right, and that's because comma separated value data typically removes extra blanks. So you can see no blanks inside the quoted values. And that's important to know because the fact that comma separated value data is built that way means that the table tool is going to require just a little simple formatting in the options. We'll get to that coming up. Here's the JCL, 30-something lines of JCL. At the top of the JCL, you can see a Endevor comma separated value step. On line 11, you can see that the requests, because there are many different kinds of CSV requests in Endevor, this one is a request for element information. And if you have already a comma separated value step, you could copy what you have into a JCL that you would use for this exercise. And if you already have a table tool step, you could copy it into the bottom section of the JCL that you're using for this exercise. The idea again is the JCL steps are the building blocks. So what's going on the bottom part of this? The second step is the table tool step. The table tool is the nickname given to the utility that you see on the end of line 23, the ENBPI U00. The A requests the table tool to process all rows of the incoming table. In this case, the incoming table is the comma separated value data produced by the first step. The options are produced, well, and let me say that over. The options are executed by table tool once before the table is opened, and then again after each read of a record from the input table. Now, line 25 is absolutely unnecessary on this particular step. It just simply tells table tool what kind of input is it expecting to read. The table type is one of those reserved words that we showed you a while ago. I left it here just to demonstrate the kinds of statements that are typically in your options syntax. So before the table is open, table tool will read that statement and know that the input value is CSV. If I were to delete that line 25, it would know that anyway, because table tool looks at the first record in the table and is able to determine what kind of input it is formatted in. Line 26 is really a more interesting line. Again, this line 26 will get run after each record is read from the input table. And what you're seeing on line 26 is one of the variables. There's a variable that's being checked to see if it has a value of n simian. If it's not equal to n simian, then you could see one of the reserved words for table tool is set to a value of y, which is a skip the row, skip that row. That means if it's not n simian, skip the row, meaning again, don't produce any output, just go back and read the next record. Now, that's the last thing you see in the options. After anything that flows beyond that line 26 is automatically going to have output produced, because the variable that contains the variable that you see referenced there on line 26 has a value of n simian. So how is the output produced? Well, each row will assign values to those variables, the variables that are derived from the heading of the comma separated value data. And those variables are then used with the model, like file tailoring is done with IBM's skeletons. So you can see in the model the format or the painted output that you want to see for your output. In the model, you have the various variables that are going to be expanded with their values and then written to the output, which is the table out. Now you might be wondering, well, where do I get those variable names? Well, let's go look at that. When the table tool sees a comma separated value formatted input, it provides for you all of the variables. Now it derives these names from the descriptive text, and in most cases, what you'll see, for example, on line 3 is environment name. The descriptive text is env blank name. Well, that's not a value, that's not a variable that you can use. You have to use a single word there. So the table tool will replace spaces with underscores. But regardless of what it does, it lists out all of the variables in a format like this. So if you're executing the table tool for the first time on a comma separated value that you've never used before, then just let it run through the table tool once. Even if you don't select anything for output, you'll still get this report from the table tool showing you what these variables are that you can use in your options and you can use in your model. This being a comma separated value output for list element action, I counted 54 variables. That's a lot. These are the same values that you as Endevor persons will see on the master display on an element. If you recall, there are like 3 screens of information that you can see by doing a master display. What was typically done in the past is someone would take the comma separated value output like this, download it to your desktop, and then open it with Excel. And if you did that, you'd get 54 columns. If you wanted a report, but you didn't want all 54 columns, then you would have to go through and delete the columns that you don't want. Well, you still have all of the rows from the comma separated value. So you probably would go into Excel and put some filtering tools, some filtering in place so that you can see in a report just the records that you want to see. If you combine the CSV utilities with the table tool, you don't need to do any of that. In fact, it's no longer necessary to look for off-host help for a mainframe report like this one. Instead, you can just simply submit a JCL and a report can be produced for you. Once again, this is the format of the output of our first example. If it were me, I wouldn't use 3 lines, but you can see how the 3 lines match up with the 3 lines in the model, because the model dictates what does this output look like. Now we're going to another example. This one is formatted a little bit nicer than the first example. This again is reporting the same kind of comma separated value data, data that is built by the Endevor CSV utility. However, this time you can see it looks more like a report. This report is able to be produced in 40 lines of JCL. Once again, there's a comma separated value step and there's a table tool step. So if you already have a comma separated value step, it's a good idea to just copy it into the JCL that you'll use for this example. If you already have a table tool step, it's a good idea to just copy that step into the JCL that you're going to use for this example. And then it's just a matter of tweaking to get the different results. Now, there are option statements in this example that are devoted to selecting records and formatting. Here's the JCL. Again, you can see there are just 2 steps. The one on the top is a comma separated value step. You can see it on line 8. We're only going to show just that one piece of that step to show it's there. The table tool step is a little bit different. It runs the table tool in the same way, but you see there are more option statements in this case. This time we're going to build a report. Notice the very first line of the options. The options again are executed once before the first record of the table is read, and then it's executed by the table tool after each record is read. So after each record is read, the row number is going to tell you in the options, what row am I on? So if I'm just reading the first row, that line 26 is an instruction to table tool to build from a model something, whatever is in the DD name of heading. This is like the file tailoring, do it now. This is just going to write the heading. Whoops, what happened here? Okay. Yep, momentarily, whoops. Lem, are you there? Yeah, okay.
Oh,
I don't
you
know
keep
what's
bouncing in between. Yeah, it's hard for me to know what's going on from this end.
Yeah, okay. Where were we? I think I'm showing where I left off. Okay.
I think so, yeah.
All right, good deal. So we were talking about line 26. Line 26 is going to find a DD name called heading, and you can see the DD name heading right here at line 23. The content in that DD name is basically the heading on our report. Now, this is an expansion of a model. You can see that the command here on line 26 is build from model. Heading qualifies as a model, but there are no variables in that content. If there were variables in there, those variables would be expanded. But because there are none, the content as is just written to the output. Line 27 is an if statement. There's one of the variables that is in the comma separated value data that's a date field. And we're checking to see if that date field is greater than January 1st, 2020. If it's greater than that value, then we're going to throw out that row. we're going to throw out that record. So basically, this step is only looking for items in Endevor that have a date older than that value right there. And beginning on line 28 through 32 is the formatting that I was telling you about. The element name, especially in a comma separated value data, is not always 8 bytes in length. You might have a much shorter element name. You might have a shorter type name, system name, subsystem name. What you're seeing here on these lines are just simple rex commands to reformat the content of the data in those variables. Line 28 says, for example, element name is a variable, and its value is to be reassigned to its current value, but made into an 8-byte field with the non-blank character shifted to the left. And that's the kind of thing that you would want to do for formatting, especially for comma separated value data. Otherwise, you'd see the data skewed like we saw in the comma separated value data itself. Lines 29, 30, 31, and 32 are very similar, just formatting the fields. 32 is a little bit different in that you see the name of the variable on line 32. Who did it? That's a variable name that we just made up. We just pulled it right out of the air. And you can do that with the table tool. That's a variable that we just made up, but we assigned it to a value that was calculated from one of the variables on the input table itself. And it's just a shift left value of that data. So after the last record there, 32 is done, then it's time to build output. So if a record has surpassed the if statement, it is still being processed at this point, then the model will be used to expand the values of the variables that are within it. So you can see the model on line 35 and 36. You can see all the variable names that are either in the comma separated value data, and the one on the very end, who did it, that's the variable that we just made up. We just made that one up, and it only needs to appear in 2 places in this step. And here you can see where they are. This again is what our report looks like. And you can see that, in fact, especially in the type column, not all of the type values have the same width. In the comma separated value data, the word copy would not have any spaces after it, but because of the formatting that was performed by those options, you can see that everything lines up nice and neatly under the heading as it's intended to. So if you were to take these 2 examples, where could you go with them? You could take these 2 examples, table tools, jobs, and go find for yourselves what are the abandoned elements, and you can use your definition for how do you know what an abandoned element looks like. You could run table tool to report or count elements by CCID, sandbox, dynamic environment name, user ID type, processor group, and on and on and on. Virtually anything that you see on the master display, and you know that not all 54 of those fields are represented on the standard reports. But if you use a CSV utility and a table tool, you can report anything that you see on a master display. If you change the comma separated value step itself to report package information, and we're going to do that here in one of our subsequent examples, then you can use the CSV utility and a table tool to do package reporting and not element reporting. Okay, we're going to go to another example. This one is especially interest to Endevor administrators. This one, you'll notice, is not a report format at all. In fact, the table out is a DD name. You can point it to anything you like. In this example, the output is going to a data set and a member name. The idea here is that we're reporting all of the processor group overrides that we have in Endevor. Some sites require processor group overrides and live by them and maybe have hundreds of thousands of them. Other sites maybe use them temporarily and then want to make sure that they get deleted. This example covers both of those scenarios and lets you do what you need to do with processor group overrides. Now, the interesting thing about removing a processor group override is that you don't have to tell it what's there. You just delete, like you see here. This is the SCL for the batch Endevor administration. You can delete the processor symbol. You don't have to know what's there, but you can see what's happening is for a administrator to review and determine whether or not the override needs to be deleted. There's a comment in front of each delete statement. The comment tells you what is the user ID that put this processor group override in place, when did they do it, what is the symbol that has been overridden, and then what's the value that they placed as an override. All of that is in the comment text, and none of that is a part of the delete statement itself. But if you can build this kind of data, which you can using, again, a comma separated value utility and a table tool, this can go a long way to helping you do your Endevor administration. This is just an example. So what does it take to build something like that? Now we're talking about, again, just 2 steps in 47 lines of JCL. The first step is a comma separated value step. And if you already have a comma separated value step, you can copy it into the JCL that you're using for this example. And the second step is the table tool step. Again, you could copy an existing table tool step into what you're using for this example. Now, we're strongly recommending that if you take this approach to doing Endevor administration, that you comment generously. You can comment and build your own audit trail by using comments like the ones that you just saw in this example. There are options in the table tool step, and in this case, the options determine whether or not to comment entries. Let me go back and then I'll come forward again. Notice the first item in this selection is not commented. So if I were to execute these statements, the first processor group override would be deleted. The one in the middle, the one that starts with now HARD A99, that one we've acknowledged beforehand. That's a keeper. We want to report it, but we don't want to delete this one. Maybe it's a permanent override that we want to hang on to, or maybe it's a temporary one, but we're not ready to give it up just yet. So you have the whole thing is reported in this data, but it's commented out so that if this is executed, that second one listed is not going to be deleted. Okay, back to our JCL. The first step is the comma separated value step. Unlike the first 2 examples where we were listing element information, this time you see a comma separated value utility executing a request for processor group information. Again, the options are executed once before the table is opened, and then they're executed again after each row of the table is read. So line 32 says, if there's a variable that's a blank, throw it out. That variable, by the way, happens to be the variable that tells you there is an override at the processor group level. So if you don't have an override, there's no reason to do anything with that processor group. Notice line 33. 33 is a brand new variable made up out of the air. Its name is asterisk, and we're giving it a blank as a default value. Now you'll notice if you take a sneak peek down to the model down at the bottom of the slide that asterisk is the first thing on each detail line of the delete statement. So if it's a blank, you'll see a blank in the output, and the delete statement will take effect if you move forward with that output. If, on the other hand, you come back to line 34, if you have a keeper, if you know beforehand, well, we've got to keep these overrides, you can put if statements like the one on 34 that says, if you have this condition, then the asterisk is really an asterisk and not a blank. It's that simple. So you have 3 lines of options. Your model is tailored to coordinate with the options to give you the results that you see And again, because the table tool is seeing comma separated value input, is going to list the variables for you. And here you can see different variables than what we saw in the first two examples. These are variables that have to do with processor group information and not element information. If you were to run the comma separated value and the table tool at your site, you'd get the same list that you're seeing here, and the same variables would be available to you. Here again is the output that's produced by this example. And what you define as keepers, as you can see in the second entry here, is up to you. And if you decide to review output like this and then to go forward, that would be the appropriate thing to do. If you want to clean up your processor group overrides, then you take this output and feed it into the batch administration utility, and those overrides that you no longer want to keep are deleted. Now, where could you go with this example? One of the things that you don't do is you don't do it the old-fashioned way so often, maybe never, and that's why this first one is crossed out. It used to be that you would run the entire batch administration, do the brain dump from Endevor to get the tens of thousands of lines of output that contain the definitions, including the part that you want to change. And then you would go through and edit that massive amount of output to change it to what you want to be different than what's configured currently. And then you'd run the batch administration again to load that massive amount of data back into Endevor. You'd have to be careful to provide your own audit trail. You might still be doing this. We've got it crossed out because we think if you adopt this practice of using the CSV and the table tool together for your administration, you'll be doing this exercise less frequently. The foreground activity is definitely discouraged, at least from this consultant's standpoint. You don't have any audit trail at all if you make changes in the foreground. If you're configuring something brand new, that may be different, but making modifications to something in the foreground is not necessarily a good idea. So taking this approach, you can define new Endevor objects from existing objects. For example, if you see a processor group and you want to create a new processor group everywhere that you see an existing one, that is an appropriate thing to do. You can create new processor groups, new types, new systems, new Endevor objects of any kind. The models that are provided with Endevor are in the CSIQ sample library. You'll see all kinds of models that are provided with the BPI, the best practices implementation, which is the use of the table tool with the other kind of tables. But the models don't matter. You can use any model with any kind of input table format. And these are plenty of examples in your CSIQ sample library. Again, we encourage freely commenting to provide your own audit trail. What is it that we're doing? What is it we are trying to do? So you can always recover also if you need to go back and put it back the way it was. Once again, the point here is the construction that supports this kind of output is basically building steps in your JCL. So your job steps become the building blocks. Okay, we're going to do this example is the next one. I'm going to try to hurry here. I see we're going. This one has nothing to do with Endevor. This one, I'm going to show you a JCL that just simply takes a high-level qualifier and lists a report like this one showing all of the data sets that are found using that high-level qualifier and some detailed information about each one of those data sets. Now, if you go into TSO and do a 3.4, you can get a list similar to this, but you can't get the member names, not the member names, I'm sorry, the member count, which is the last column on the right-hand side. So this is just a matter of submitting a job after specifying what is the high-level qualifier, and this is a report you can get. So what produces this report? In this case, there are 36 lines of JCL. Now, we promise this has nothing to do with Endevor, so you won't see the Endevor CSV utility here. The first step is in ID cams, which is just an IBM utility, which can take a high-level qualifier and produce some output showing just the dataset names. And of course, the second step is a table tool. The options in this case get a little bit complicated, but I'll show you what that looks like when we get there, go forward. If you're not familiar with the kind of output that the ID cams can produce for you, here's an example. In fact, this is output that we produced on one of our Broadcom demo systems. You can see the third green line down from the top. There's a list cat level. That value in quotes is the high level qualifier. That's the only variable in the JCL that we're asking ID cams to give us a list of dataset names. Now, unlike the separated value data, there's nothing in this output that tells us what the fields are. What are the fields? What are their positions, or how can you locate them in the data? But that's okay. If you look at this output and examine just those lines that have NON VSAM in column 2, these are the lines that you want Table Tool to see, and you can have Table Tool ignore all of the others. So how do you do that? Here's how you do it. The Table Tool will look at the first record and it will say, well, I don't know what this is. I'll see if there's a position DD statement, and there is. The position DD statement is what you see on lines 15, and 16 and 17 are made up variable names. You can pull those right out of the air. What do you want to call this field? And for each field that you name, you can specify what column it starts in and what column it ends in. So there's no math that's required here. You can just see those columns off of the previous display. You don't have to calculate any lengths. So we made up a variable named non-VSAM in mixed case. And let's go see what the options do. Again, the options are executed once before the table is open, and then they're executed again after each row of the table is read. So if the row number is 1, we're going to produce a heading, and we saw that in one of our previous examples, so we're not going to dwell too much on that. Line 20, we're testing that variable name that we've made up that you see listed in the position data. Does it have a value of NONVSAM? If it does not have that value, then we're telling Table Tool to skip that row. So it's just basically going to ignore that row. So the only time the next line executes, line 21 in the options, we know that we have NONVSAM as a value to the variable defined on line 16. We also know that further on that line out in column 18 is a dataset name. So on line 21 here, this gets a little bit complicated. I apologize to those who are not familiar with the IBM tools here, but this is Table Tool calling an IBM utility that you can do a query on a data set, and it will return back for you a wealth of information about the data set name, including its data set or its record format, LRECL, the number of members, and so forth and so on. Now, earlier we saw some formatting that was being done on one of our examples, and we're doing formatting in the options on this example too. Notice on line 22, the data set is being formatted to have the non-blank characters shift left in a 44-byte field. The other variables, these are variables that are produced by the list DSI command, and you could do a Google search on the list DSI if you want to know more information about that. But the formatting on lines 23, 24, 25 is a shift to the right, so that the non-blank characters are shifted to the right. Any additional characters that are needed or blank values inserted on the left. Our model, you can see at the bottom of this slide, the model is just a list of the fields that we want to see on the report. When this runs, again, this is what you see. This is the report that's provided. And here you can see also, you can see better the effects of the left and the right formatting that you can use inside of your options. the dataset name was formatted to the left as a field 44 bytes long. So you can see that in every case, the first character under the D for dataset is a dataset name. Any extra characters are on the right-hand side, but in every case, the dataset name is formatted to fit to be exactly 44 characters. On the right-hand side of the report, you see just the opposite. Those variables that were shifted to the right using the right command, you can see that the extra spaces are on the left-hand side. And that's exactly what you might want. Again, this is all tailorable how you prefer to see it. So you can code these things the way you want. So what could you do with this kind of output? And I'm going to have to hurry up. I realize that. But suppose you want to find certain data sets. It could be empty data sets, maybe data sets that are not PDSE, maybe data sets with the wrong block sizes. Then you want to take action. Maybe you want to delete them, rename them, or just simply rebuild them. You can do calculate and reports. You can see from this example that you can report from almost any kind of input. That input that we were using on this last example was just the basic ID cams report. So if you can identify the positions of the fields, you can report from that data as well. I'm going to hurry through this one because we're just about out of time, but this is an example that requires multiple comma-separated value utilities, and it merges output together. If you're familiar with Endevor, you know that you can do a CSV on package information, but it's a separate CSV for shipment information. For combining the outputs of those two is something the table tool can do. This one is a little bit larger of the JCL, but again, the building blocks or steps that you have existing, you can copy them into the JCL. Just very quickly, you can see on line 14, this is the first of the comma separated value steps. It's asking for package information. You see that the package ID is wildcarded in that step. In the middle of the slide here, you can see a table tool step. It's using the Rex-based date routines. It's trying to figure out what is today's date, what is yesterday's date, and what is tomorrow's date. One of the date values allows you to do math or arithmetic, and it does that just once because of the parm list. And I'm about to talk a little bit about the parm list. Once it identifies a package that has had activity in either yesterday, today, or tomorrow, you can see on line 89, it's going to take the variable that's in the first CSV extract, and it's going to construct a CSV command for the next CSV extract. And because the comma separated value data is what's seen by the table tool, a report like this one again is provided. This is what the report looks like. And I'm going to talk briefly about the parm list, and then I'm done. I'll try to be quick with this. You saw in that previous example that the parameter value on the table tool was parm list. That opens up a whole new realm of the table tool. The parm list, if it sees it in the parameter value, also expects to see it as a DD name. And here you can see an example. The DD name allows you to enter as many records as you need to or as you want to. Each line has the DD name for a model, the DD name for a table out, DD name for options, and a parameter value. Now what you could do is if you wanted to make multiple passes through the same input file, you could use the parm list. You could have a DD name for each pass, a DD name for the model that produces a report 1 and the options that drive that report 1. You could have a DD name for the second report and its options for the second report, and so forth for the third. 3 separate passes. Quite honestly, more frequently, you'll see the parm list used this way. And that is, again, the parm list will itemize on each record or each row. You'll have a DD name for a model, DD name for a table out, and a DD name for options. This is more typical. In this case, the DD name for the model and the DD name for the table out are the same, and you can see them on the same step where the parm list appears, and it's just simply a DD with DD dummy, which means nothing happens. And you see the parameter value is a 0. That means we're not expecting to read or write any records. The only thing that happens in that pass is that the rec statements and the defaults are executed. And you can see, oops, here I get lost it again. Here you can see that these variables are being initialized to 0. On the second pass, you have a real model, a real report out, count them, and I'm gonna wind this up very quickly here. But this is the second pass, which is going to go through all of the input records, calculate values, and you can see the calculations down here in the bottom part of count them. We're going to increment this variable by 1 when we see some of the things that we're wanting to calculate. If there's a field on the input called some number, we're going to calculate a total of all of those fields in our input. And then on the final pass, we're going to report the calculations that we found. And that's what this is. So the model that you see here is summary, and here's what the summary is formatted to look like. It's the painted image of the output, and it's being written to the same output that the second pass was written to. So this is a parm list, and I ran this on a very simple case, and you can see what happened. The detailed report is the first 40 lines, which I've hidden because we didn't really get into that. But the summary that's produced at the bottom accurately showed that there were 40 items reported. The total of the sum number was 10,000, and so my average is 250. Okay, now I'm really almost done. There's quite a bit more that we haven't covered with Table Tool. There's certain considerations for using Table Tool in a processor. There's more that can be done if you're not concerned about limiting the amount of recs that you write. There's quite a bit more that can be done. If you want to get more information, there are many places you can go. We mentioned the GitHub location. That's the second one listed here. Table Tool is also found in the tech docs, and there are examples out on the community website. And Lim, that's all I have. Thank you.
Great, thank you, Dan, very much. We do have a couple questions. I don't know if we'll be able to get through all of them, but we can try, and anything that we don't get to, we will make sure that we follow up with you after. So the first one is, kindly share how we can simplify auto bind requirement using this tool in a COBOL generate processor. We also have bind overrides.
Yes, as I mentioned, the table tool can play a role inside of your Endevor processors, and we have this concept that we've called extended options. That's going to be quite a bit to get into for today.
Okay. Yeah. So Dan, if it's too involved, I can definitely just capture this person's information and get it to you, and you can follow up with them afterwards.
Perfect.
That's fine. Yeah. Perfect. And then let's see, that there's another question with regard to the variable fields in TTK sensitive. How do I list the fields in the TT? All right, I think it's possible. I'm gonna put you in touch with this person as well, just to make sure that because I'm not sure I'm fully understanding the question. There is another question in here. Is the session recorded? Yes, the session is going to be recorded. And then I have another person asking, can you email examples as a text file?
Email examples as a text file. Yeah, I could, if we could get some clarification on that question too, Lem.
Yeah, all right. Yeah. So folks, thank you very much for the questions. I think all of these we're going to want to follow up with you offline, just to make sure that we fully understand the question in the context, and so that Dan can put together a good detailed answer. So with that being the case, I think we can go ahead and wrap up. Dan, thank you very much. Oh, go ahead, Vaughn.
Yeah, I was just going to say, if the text file question is like, I'm assuming text file specifically because of restrictions that come through email, attachments being stripped, etc. We could also, maybe provide some examples via a support ticket. and an attachment.
Okay. Okay.
So we'll
Okay.
figure something out, but yeah, do talk to us. I think Dan will follow up. And yeah, sorry, back to you, Dan.
No, thank you very much, Vaughn. And that's actually a really good point. Yeah, the short answer is we will definitely find a way to get you examples. All right, we're going to go ahead and wrap up. Thanks very much, everybody. Keep an eye out in the Endevor community for the replay and also for any upcoming webcasts. We're going to be hopefully be scheduling some new ones soon. So have a great day, great rest of your week, and we'll talk to you next time.
Great. Thanks, everyone.